Hello again. This is the MATLAB project number 2, specifically dealing with analyzing the frequency magnitude spectrum of specific signals. One of a single tone, then one in which we use this slider to produce another tone with a different frequency. And then here in the bottom we have the second part to our project, which has to do with recording a sound like a voice and then playing it back and then analyzing the spectrum. So let's start from the beginning here. Taking a look at our code. Well, let's start with design view. So in design view, we have our original table here, which is specifically going to show us a tone that I actually just created by doing just a solid whistle for about 3 seconds. And then, sorry, my cat's right here. And then we'll have a single tone, which will, Belle, get out of here. Come on. All right. Sorry about that. And then over here we'll have a slider, which we can change the frequency of the sound. And it'll plot the magnitude spectrum. And then we have a second part over here, which will record a specific sound that I'll be able to, create, and then we'll have a playback. So going into code view, what we got here is button push function. This is for the single tone. So this is the slider. So we have a frequency set here, we got a sampling rate, an actual period rate. We'll have a n, which is basically the number of bits that we're going to be using. And then we have our cosine function. And then on top of that, we have this XFS shift, which will give us our positive as well as our negative magnitude. And then we have other things that'll tell us about the for the graph size itself, and then this will play the sound based off of the new frequency, and then obviously it'll plot it as well. And then we also have this button push function, which is record button. So this is for the second part of the project. This will actually record what I say, and then it will auto-write it to an actual .wav file, which is pretty cool. And then our second button is the playback button. That'll actually give us the original sound of whatever we recorded, and then again we have it being plotted in a similar fashion to up here to create the magnitude spectrum. On top of that, we'll have our original sound button, which is actually just the sound of me whistling. But we still have the ability to change it based off of the slider frequency values. So let's go and run this program. All right, so right here we have the original sound. Let me see, I'm gonna turn my sound on. Whoa, sorry about that. I'm currently listening to music. All right. All right, original sound. So right here, this actually takes a fair amount of scrolling in. That's primarily just because of the multiplier that we have on our x-axis. But you can see that we have two different magnitudes here. We have this positive and this negative. And obviously when we do a DTF, we really only care about the positive side of the frequency, but we can still see its conjugate here, which is great. And then if we want to change this slider, I'm going to do it right there and play the new tone. The interesting thing about this is we can actually play multiple of these tones, and we can actually see how the space in between them changes. As we go up on this slider, we'll actually be increasing the distance between these two, and in turn we'll be increasing the frequency and the tone itself. And then as we move down further and further, we'll actually get lower and lower on the scale, if you will. So something that I found kind of interesting, I'll play it for you here. We'll start with the lower tone and then slowly move up and see what kind of strange chords we can make. Interesting, right? So as you can see, as we change this frequency, the tone increases, and as we increase the slider and as we decrease the slider, it'll decrease in tone. And then down here for number 2, we can record about a 3-second snapshot of whatever sound's going on, and then we can actually play it back. So let me record something. Hello, 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 hello. So obviously I'm kind of kept that at the same tone, but since since I'm saying hello multiple times, and since there is an inflection in my voice, it is likely that we're probably going to get 1 or 2 main peaks here, and then we'll see smaller peaks that will have a DTF energy leakage, which I'm not too surprised about. Hello, 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 hello. So as you can see, there's a spike here, there's one right there, one right there. If I play this back again, I'm pretty sure it only records 3 hellos. Hello, 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 hello. It does 4. So I'm not too surprised by the leakage that happens in between here and all these different peaks that we see. But it is still interesting that we're able to see that this main frequency point right here, if we scroll in, it's kind of right around 120 hertz, which is kind of interesting. I have a lower voice, so I actually imagined it to be kind of smaller. We can see over here, this is probably going to be around 50. 30. Close. But anyways, there's more information on what I think about this, and I'm kind of breaking down, analyzing this more in my actual report. So this is, again, this is just for the Project 2 frequency spectrum report. This is just a part 1, I believe. Anyways, thanks for joining. I hope you enjoyed the cameo from my cat.